Hello and welcome to Random Hacks. So today we are going to look at one of the interesting project what is called the Pulse Width Modulation or PWM using Arduino. In simple words, it's a project to control the brightness of LED. Pulse width modulation is a basic idea in the digital control system. This can be used for controlling the motors, brightness of light, or many such things. So let us look at this more carefully. Let's start with the random hacks, and I am going to introduce you basics of pulse width modulation. So let's first start with an example for analog control. Analog control can be simply viewed with the following circuit, where you have filament lamp is connected with the circuit. You have a switch here and a resistance. The battery is supplied. When the switch is closed, you will have your light glowing, and the brightness of the lamp can be controlled with this variable resistance. So you can make it dim or bright, and fairly simple analog control. In a complex analog control, in addition to switch, you have a resistance and the capacitance built together to control the analog system. On the other hand, digital systems are quite different. Digital systems can be easily modeled with an LED or the circuit given here. When you close the switch here, you have the voltage supply, and the LED will work or not work depending on the voltage. In the beginning, when the voltage is small, the LED will not work, and as the voltage reaches about 1.5 to 3 volt, current will flow through LED in one direction. It's a light emitting diode, and it will start emitting diode, and when the voltage increases, most likely your LED will get burned. So there is no way of controlling an LED based on the resistance, because changing voltage will have no effect on this LED. So one need to find out an alternative method to change the brightness of a system like LED. Let us quickly look into details of that. One of the simplest idea is to use pulses. Pulses basically means that you have 0 volt and the reference volt, which may be 5. Digitally, it can be thought as a 0 and 1 state, and your signal would be changing periodically and sharply in a square wave manner from 0 to 1. It basically flips between 0 and 1 within a given period. So this you can call the period of the pulse. When this kind of a signal is attached to an LED, when the voltage is 0, the LED will not work, and when the signal is flipped to 1, LED would glow. Based on signal is 0 or 1, whether LED will work or not work. Now we know that these pulses can be controlled, and we know that this pulses will keep continuing on this axis, and this will make LED go on and off based on whether it is 0 or 1. If the frequency crosses certain limit, when the flicker rate beyond between 40 and 50 number of cycles per second, human eyes will not be able to see the flickering. This is the basic concept used in the movies, where you have been shown 48 frames per second on the movie screen. This is usually 24 frames, and each frame is repeated twice, so that you have 48 frames are shown, and your eyes and brain will not be able to distinguish, and you see them as a continuous sequence. Same thing happens with the LED, and you see when the frequency crosses about 50 or so, you will see the continuous light coming from the LED, because we are not able to see them. Of course, depending on the detector you use, modern digital cameras can scan 60 or 30 frames per second, or you can have a sensitive light sensors which can scan much faster, and accordingly you can determine what should be the period in day-to-day life using much smaller frequencies. So frequency of the order of 500 hertz period, one would not be able to catch it up with any of the day-to-day detectors, such as webcams or movie cameras and things like that. So it would be suffice to use such kind of a frequency. So we will basically checking this concept. One of the important concept in the pulse width modulation is a duty cycle. The duty cycle of a pulse is the percentage of time during which the signal remains high in a given period. One of the example here is a duty cycle 100. Duty cycle 100, there is a period has no meaning. the lower state here is 0 and the upper state is 1, and the signal always remain 1. It's like a DC offset value, and such a thing has a duty cycle 100%. It is always high, and you connect to LED, it is always going to glow. There is no flicker, there is no period, because it's all high. Next example is what you have is a duty cycle. Here your signal keep on going from say for a large period of time. Given one period you have from 0 to t, you can see half the time it is 0, and in the second half it is going to be 1. During one cycle, exactly half period it is 0, and exactly half period it is 1, so it gives the duty cycle 50%. So we can reduce it further, and then we can have a duty cycle of a 10%. In this case, in a period, 10% of the time the signal is going to take the value of 1 or high, and the rest of the time, 90% of the time, it is going to take 0. So you have a duty cycle 10%, and the last example is a duty cycle 0, where the signal remains 0 all the time. And interesting thing would happen when you connect an LED to this. Now we assume that frequency of this signal corresponds to around 500 cycles per second or so that we do not see individual cycle when we connect it to LED. In this case, LED will be brightly glowing all the time. In the second case, when there is a 50% cycle, we see that the light is on only 50% of the time in a period. So intensity basically integrated over the period reduces to 50%, because we are not able to see individual cycle. We see averaged light over a cycle with our eyes or any other low scanning devices which you have. So that is where this LED look half dimmer, intensity reduced. When you have 10%, LED weakly grows, because in a cycle, time in which the LED is on is very small, about 10%, and when it integrated, it reduces the intensity quite a bit. In the last case, what we have, duty cycle is 0, where the signal is 0 and you don't see at all. So now by controlling the duty cycle, we can also control the intensity or the brightness of the LED. In the first case, amount of integrated power per cycle is going to be the maximum, and in this case it is 50%. And so by controlling the duty cycle, you can change the brightness of the LED or power supplied to the digital system. So this is the basic idea how we control the digital signal, and we will see it done through a LED, whether it really brightens or reduces the brightness by changing the duty cycle. So that is what we are going to do it through an Arduino. One can use analog systems such as IC555 and similar system to control or to change the duty cycle of a square wave. On the other hand, this can be easily and more elegantly done using the microcontrollers. We use microcontroller to send a signal to LED in this case, or any digital system for controlling. We are using one of the most popular microcontroller board, which is called Arduino. Arduino is a microcontroller board which can be easily connected to computer, and necessary coding can be simply sent using a PC or laptop. In the Arduino, the main brain or the processor is the ATmeg8U2. This is one of the controller which does all sorts of jobs necessary for sending the signal, receiving the signal, and doing some minor manipulation. The one of the other important component is the frequency at which this microcontroller works, around at 16 megahertz. So that fast it can send the signal or receive or process the signal. Now we have various pins connecting. They are given from 0 to 13, which are basically digital pins. That is, you can send the digital signal 0 or 1. On the other side, we have A0 to A5, which are analog pins. Now on the other side, we have a USB port which can be connected to the computer, and you can flash in the code which you needed to put on the microcontroller to control the various devices. We also have a 12-volt power supply. One of the advantages is that once you flash the code into the microcontroller, you don't need the computer. You can power this microcontroller based on the USB power supply 5-volt, or you can also supply a DC 12-volt power supply independently, and this can happily work on any one of them. We also have a reset button which can be used to reset the code, and we can flash it in again. So this is the basic idea. We can use the data from the digital or analog input or output and then control the system. One of the interesting thing is that it also provides you a 3-volt and 5-volt power supply. Though not much current can be drawn this, but it is usually enough for small circuit to operate. It has a 3.3 volt, which is very popular among the various robotics interfaces or sensors. It also supplies the 5 volt, and it has a various grounds. You can see many grounds which can be connected to these in order to operate the external circuit for this microcontroller board. Arduino board can be easily acquired, and they are not too expensive. They can be used for doing many fun projects as well as a serious robotic project. So it is good to have one or two of them around. Let us quickly look at the circuit which we are interested in flashing this LED. What we are using is one of the digital output, that is a pin number 4 is connected to an LED. We use a resistor 330 ohm. I am actually using 470 ohm. This because the digital output is usually 5 volts, whereas the LED will not work at that volt. LED would work around 3 volts or so. So one need to drop voltage to 3 volts, assuming that around 20 milliamps power is consumed by the LED. So that comes out to be about 330 ohms, more or less around that. It would work fine. So we can have this LED glowing. Once we have this is the hardware section of the microcontroller. We also have a software section. Now that we have seen hardware of Arduino board, let us look at the software portion of it. Basic idea here is to write a code to the controller and push it on to the microcontroller board, and then you can run it whenever you need to do your job using the microcontroller. The Arduino IDE or the programming environment window would look something like this. You can install it very easily using Arduino site. So once you have installed, you can enter your program. Before that, you need to select your board. Arduino that can be done using the port, and you can see in the USB, you can see the Arduino, and once it is connected, you can simply type this in and upload it to the Arduino microcontroller using this button, and it will be sent to this. This particular one doesn't have anything. Okay, let's quickly look at the coding part needed for blinking an LED. We are using pin number 4. Programming here is essentially in C style. Those who know C can easily do it. Otherwise, let's go through it. The basic structure of a program consists of a setup, which is the initialization of codes. Necessary variables and pin configurations are set up here. Then we have a loop which continuously runs without ending. Here is the main code which is running continuously in the loop till you switch off the system. Let us look at our initialization. We are using pin number 4 that is defined. We have two variables here, period and the ups. The period is a time period in millisecond, that is period is 200, and ups is 100, and downs is basically period minus up. In the setup, we say that pin 14 is configured to output. That means you can send the digital signal to the pin number 4, and that is basically only setup which we have. Once we have this, the loop basically does is that it sends up a high signal to the pin number 14 and then wait up number of millisecond, which is 100 in this case, and then it sends a low signal, and then it waits for delays number of millisecond, and then this would continuously producing a square pulse with the period of 200 millisecond, low which is 100 millisecond, and high 100 millisecond. So totally you have a duty cycle of 50%. Now you can change this period. You can change the period and ups and down, and you can see that at some stage when it is very large, 1 second or of that order, you can clearly see LED blinking. And when you increase it to of the order of 50 cycles, or a period is about 200 seconds, you can barely see it, and beyond that you can never see it blinking. It essentially looks like continuously glowing. Here we have used duty cycle of 50%. We can change this based on this variable and see how the LED brightness behaves. We have had enough of theory. Let's get some hands on. Let's first see what are the components which we need for doing some basic experimentation on the pulse width modulation. You can always do this using analog circuit, but we are using Arduino, so we need one of the Arduino boards. These can be easily procured. They cost about 200 to about 500 rupees depending on who is making them. They are very handy to have around if you are interested in the digital signal control or hobbies such as robotics. Course, to control, we need a standard LED with the resistance which is around 300 to 400 ohms, or around that would be enough to reduce the voltage from 5 volts, which is usually digital high, to operating voltage of LED, which is about 2 to 3 volts. We can solder this together to have little neat work. If you think your digital soul is not agreeing with the soldering and things like that, you can simply twist the wires around. You can see that I am not very good in soldering, but however some small soldering can be easily done, and end product would look reasonably good, as you can see here. First thing to do is basically to test. This we can do by connecting ground and 5 volt supply on your Arduino board. This 5 volt supply is used for connecting external circuit, and you can see it is working nicely. So we can go ahead with our experiment by connecting it between the pin 4 and the ground. Once the code is written, this is how it looks, and we can flash it on to the board using this button, and you can see the data being transferred. Now you can see that it is blinking once every second. Total cycle is around 2 seconds. So we can reduce the cycle by changing this time. Here duty cycle is a 50%. Up the time it is up and up the time it is down. I have reduced the time to 200 millisecond. You can see it is still flashing. So we can further go down. We make this to 10 millisecond and 10 millisecond. Total period about 20 millisecond. We can flash it on to the board. Again, we can flash it as many times we want to. Now you see that we no longer able to distinguish each pulses because our eyes is integrating the signal much slower than the pulse which is given. Now, one of the advantages here, once this program is flashed into the microcontroller, we don't need this computer. We can simply disconnect it from the computer and connect it to any USB power, and that would be simply running in the same way. Now we can test with the various duty cycles. We have a period of a 20 milliseconds. Now I have divided into equal half, so it is a 50% duty cycle. Let's first put it a 100% duty cycle, that is period up should be equal to this. In this case, the LED is fully powered, and you can see this is the brightest possible position. We can reduce to 10 millisecond, so this makes this to 50% duty cycle. I'm not sure whether you are able to distinguish this or not. The LED brightness has gone down a little bit. Let's reduce the duty cycle to 25%. That is period at which it is high is about 5 microsecond. Let's flash it again, and now we can see that LED power is a much lower. Now I reduce up to only 1 millisecond, that is on the high, and the rest of the time it is low. Duty cycle here is about 5%, and you can see correspondingly LED power has gone down. Can make it 0 duty cycle, so it's down all the time and LED will not glow at all. This is how you can increase the brightness of LED or change the brightness of LED using pulse width modulation. We can replace this LED by motors, which can speed up, speed down as you want, or change the duty cycle, laser pointer, and you can control the intensity of a diode also using the same idea, and we can control lot many things. It's a powerful technique. We will use it, apply it for the various fun aspects with the Arduino pulse width modulation.